Yeah.
We are now. Continue. Right. Good morning, everybody. My name is James, and I think for those of you here a little bit earlier, Debbie introduced that I work with the research software group in advanced research computing. So my sort of role is basically kind of on the applications team. So we manage the kind of installation of applications across the supercomputer or the HPC system, which is BlueBEAR. Just a quick housekeeping thing. So I'm looking over here, which is where I can see my slides and my terminal. However, if anyone talks to me, I'll look over here, which is where I can see your faces. So I know that I'm not actually looking at you when I'm talking to you, but that's why I'm looking that direction. If you want to say hello with your camera, then by all means give us a wave, and then feel free to turn your camera off or whatever, however you like to operate in these types of meetings. It's entirely up to you. But I will crack on. So this is an introduction to BlueBEAR. So we're assuming that you've probably either have had some previous experience of using Linux systems, or you've been on the Introduction to Linux course, which ran, I believe, last week. So there's a kind of a baseline level, but there's nothing sort of too complicated on this side beyond moving around directories in the terminal and occasionally copying files. So this is an introduction to BlueBEAR and crucially to batch computing, but we will also touch on one of our other services, which is BlueBEAR Portal, which is a slightly different route into using the HPC system. So kind of broadly, we'll talk about accessing and using BlueBEAR, how to run jobs, so that's batch jobs on BlueBEAR. We'll cover an example job, and then you will have an opportunity to workshop the stuff that we've covered so that you can test it out and ask any questions. And we will also sort of briefly touch on other BEAR services and information. So BlueBEAR is not the only facility we provide, and there are various different facilities, and they can get slightly confused. So BEAR stands for Birmingham Environment for Academic Research, and it is run by Advanced Research Computing, which is a subset of IT services, just to kind of add another kind of layer of abstraction there. So we are a collection of services. So HPC, which is BlueBEAR, so high performance computing. We also provide storage, fast networking, a GitLab server. We are currently providing BEAR data share, which many of you may have heard of already, but that is being retired in January. Is that correct, Debbie? January next year. So I think
January 22. Yeah.
So I think we're not accepting new users on BEAR data share at the moment. But if you are an existing BEAR data share user, you should have been contacted about alternate options. But to move back, and so BlueBEAR refers to the Linux HPC system. And most crucially, BEAR services are free at the point of use. I'll touch on these a little bit later again, but GitLab, so that's our on-site Git hosting. So many of you will have heard of GitHub, which is where kind of a lot of online open source sort of projects take place. The difference being with GitLab is that we host it on site, so the data is stored actually in the data centers on campus. So there are obviously benefits to that. Likewise with the research data store, so that's on campus stored data. It's not a cloud service that is sort of floating somewhere that we don't quite know. So that is accessed for up to 3 terabytes of data storage for your projects, and we thoroughly encourage you to use it. And in fact, if you are using anything on BlueBEAR, you will need access to some kind of research data store location in order to kind of process your jobs. But that will become hopefully a bit clearer as we proceed. So BlueBEAR is currently in its 3rd generation, and it's been there for a little while. So its current generation is essentially a rolling upgrade generation. So BlueBEAR is what's called a heterogeneous HPC system. So many HPC systems are homogeneous in that they are funded, and you will essentially buy an entire system that is identical. So all the node types are the same generation. You might get some variation. Some of the nodes may have GPUs, so graphical processing units for particular types of workflows, but broadly speaking, they're the same system across the HPC. With BlueBEAR, it's heterogeneous, so we have different node types, which allows us to be a bit more kind of nimble in how we update BlueBEAR. So as new node types come out from Intel, we will then sort of incrementally update some of the nodes and then retire some of the older ones. And it just allows us to kind of to stay a little bit kind of ahead of the curve against potentially some other kind of HPC systems where you essentially run it until it expires and then you buy a new system. So it's more environmentally friendly in that respect as well. It's funded by the university, so free at the point of use, but research groups can purchase sort of resource which allows you to have preferential access to some of the nodes on the network, and there is more information available on our website about that. You need to register for the service in order to use it, so hopefully all of you will be on the training project for now. When this course ends at some point in the future, you will be removed from that training project, and you will need to make sure that you're on a project that can access the BlueBEAR sort of facility. So users are attached to multiple projects. So we have this sort of overarching concept of a BEAR project, and a BEAR project will contain probably an RDS, a research data store facility, a BlueBEAR facility, potentially a GitLab facility, and also occasionally virtual machine facilities. So they're all essentially attached to the project. So you need to make sure that you are on a BEAR project that has the BlueBEAR facility in order to be able to access BlueBEAR after this training is completed. Projects have to be created by staff. So if you're a research student, you will need to get your PI or your supervisor to create a project on your behalf, or add you to an existing project, depending on kind of how your research is structured. Projects are used to account for time on the cluster, so you can be on multiple projects, and it just gives us an idea about kind of what types of workflows are going on. And you register via the intranet page here.
Can I ask something?
BlueBEAR. Yes, sorry.
So what are these projects codes? For example, if you're a researcher or a lecturer in like one of the department, which kind of code for project do you need?
So the projects are named by whoever creates them. So it's entirely up to you. So broadly speaking, you will choose sort of 3 or 4 words that very kind of briefly summarize the type of research that's being done under that BEAR project.
Okay.
So BEAR projects always start with the name of the project owner, the PI for the project, and then will be just kind of a couple of words that describe.
Okay, but it's not like linked to any funding on grant or anything. I
No,
can just request it as a lecturer, for example.
No, so we do ask when you create a project, we do ask for some information on the funding, and that will be changing a little bit as we can build it into some of the other university systems. But at the moment, you don't. I mean, there's more information on the kind of page as to how kind of the information.
Okay.
Is used. But
Thank you.
There's no fixed sort of format for the naming schemes or anything like that.
Okay, thank you.
So batch computing is quite different. If you're used to a kind of model where you have, particularly in the case of a kind of a GUI editor, so you load up your GUI editor, you provide it with some input files, some instructions, and then you set it running, but you're essentially there in attendance whilst that's going on. The same with a command line interface based workflow. So we talk often about kind of CLI, command line interface, when we're talking about working in a terminal, but essentially you can also kind of sit there and be present during that workflow. You execute the commands, you wait for them to complete, you see the results. With the batch workflow, the idea is that you don't have to be present to do that. So essentially you package up all of the instructions that are required to run your job. So in the case of working in the kind of CLI environment, the commands that you would type in to the terminal are the ones you essentially put into the script. You then pass it over to what's called a scheduler. So HPC systems use schedulers to sort of manage the resource of the HPC. And you tell the scheduler a bit about how long you think your job will run for, how much resource you require in terms of memory and in terms of cores. And then it's up to the scheduler to determine how best to put that on the cluster, and you will get sort of information back as to where and when it's running, as and when that happens. So batch computing is therefore very kind of flexible, so it can be a single core job. It can be a hugely parallelized job that runs across multiple nodes, or parallel on a single node, and all that can be described in the options that you essentially tell the scheduler when you submit your job. Jobs are submitted from the login nodes. So if you haven't already logged onto BlueBEAR, you need to grab your favorite terminal. So I'm just using the standard sort of Mac terminal here, and you type SSH, your username. This is slightly different if you're working on Putty. Putty is a sort of graphical interface, but essentially it requires the same information. And then the host name for BlueBEAR, which is bluebear.bham.ac.uk. It will then ask you for your password, which is your standard university password. I should note, when you enter your username, when you're logging on to BlueBEAR, it must be in lowercase. If you try and do it in uppercase or mixed case, then it will fail. So it requires a lowercase for the username, and then your password, which is your standard kind of university login. Hit return, and you should see something like this. You may not land on login node 2 like I've done. We have 3 login nodes, and essentially they're sort of users as they log in are assigned to them in a round robin fashion. So you will end up on login node 1, 2, or 3, but they are all identical and essentially are used as a launch pad for submitting your jobs. I will probably sort of reiterate this later, but the login nodes are not to be used for any compute. They're actually very sort of resource poor compared to the rest of the HPC systems, i.e. they don't have many cores and not a great deal of memory. So the idea is that they're definitely not for actually running any sort of significant compute beyond copying files around and starting your batch jobs. So hopefully over the next kind of a few slides, if you can sort of get yourself into a similar position to being logged in, I'll actually make the slides slightly larger. So when I do this, it's very sluggish on my computer. There we go. So coming back to the scheduler, so you tell the scheduler various bits of information about your job, and we use a scheduler called Slurm, which is one of the popular. There are many other schedulers that are available, but it's quite a popular one for HPC systems. So I've covered most of this already, but essentially just to again reiterate, so the Slurm needs some information. So how long you think the job will run for, which is frequently referred to as the job wall time. So that's the maximum runtime for that job. If you pass the wall time and your job is still running, your job will be killed. So it's important that your wall time is always a little bit longer, that you leave a little bit of buffer so that your job doesn't get killed in the middle of a process. But we'll touch on that again in a bit. How much memory, how many cores, how many nodes. So that's whether your job has to exist on a single node or whether it can span multiple nodes. And then on which QoS the job should run. So that's a term that we use to essentially assign different jobs to different queues, and different queues have access to different bits of resource. And it's a slight misnomer because QoS, sort of quality of service, doesn't quite sort of apply as a term, but it's essentially the way that it's the best way that we can use the scheduler to do what we want in terms of accessing the resource and how the resource is partitioned. But again, as you start to see some real world examples, that will hopefully make a bit more sense. Crucially, there are default values for all of these. So you can just throw a job at BlueBEAR and say, run this. By default, you will only get a wall time of 5 minutes, which is very short, and in the majority of cases will not be long enough for your job to complete. And that is by design to encourage you to think about kind of what your wall time should be. So the scheduler kind of fairly applies access to the resource. So if, for example, you have submitted thousands and thousands of jobs over the past couple of days, then you may find that the next 1,000 jobs you submit are slightly down the kind of priority queue, so other users can get access to the resource of the system. There are sort of ways of optimizing certainly kind of mass submission of jobs, which I'll touch on a bit, but essentially this Slurm can handle what's called an array job, which is very good for certain types of workflow. And that will come up a bit later. Jobs must specify a project code. I say that with a caveat that actually if you are only the member of one project, so this is coming back to the BEAR project idea, then your job will always be submitted under that project code. But if you have access to more than one project, then you will need to kind of specify the project code that you want to run that job against. That's particularly important if different projects have access to different resources. So not all kind of projects have access to the same queues, the same QoSs. So knowing kind of how your job is being submitted and what project you're attached to and what facilities that has is useful. And there is an easy way to discover that quickly, which is to type, when logged into BlueBEAR, my_BlueBEAR, hit return. And I will just enlarge that slightly. So I'm the member of several projects, but if I just scroll up, so it lists all the projects that you're a member of. It tells you what your default project is. So if I don't specify my project code, I will be submitting under Carp and JJ BEAR apps. And then here are the various QoSs that I can access and which projects have access to them. So for example, if I were to try and submit to the BB GPU QoS, but I was using this training project, then I wouldn't be able to access that GPU, and I will get something, a Slurm kind of error would appear. So again, once you start to see how the system is working and how these project codes kind of get applied to the jobs, that should start to make more sense. But at a sort of snapshot, my_BlueBEAR is a useful way of just seeing what you've got access to. There are other ways which are slightly sort of less command line based, which we will touch on later as well. Let's slowly resize that. Good. Nodes are shared between users and jobs. So a node in kind of in HPC parlance is essentially it's a computer. So an HPC system is just a large number of computers that are all kind of connected together by a very fast interconnect, sort of fiber-based interconnect, which allows you to pass information obviously much quicker than you can over sort of standard copper cables. Nodes, they tend to be kind of server scale nodes, so they will have far more cores and be sort of far more robust in that sense. But because there are so many cores, it could be that a node or a computer on the HPC system has multiple jobs running on it. So if it's a 40-core node, it may have one 2-core job, another 8-core job, another 8-core job, and a 10-core job, for example. And they all run at the same time on the computer, but you can't sort of communicate between them. So they're sort of siloed on the node. And it could be that your job is actually running on several nodes, some of which are mixed with other users, some of which aren't because they're either idle, or there are situations where you can actually kind of request an entire node's worth of resource as well. And again, we'll touch on that in a little bit. A key thing to note is that jobs, if you ask for more than one core, so that's sort of more than one CPU in your job, by default, it will be spread around multiple nodes. And that may not be what you want, depending on whether you're the commands and the programs that you're calling can cope with that. So this is where kind of having some understanding about the jobs that you're running is useful. And the fact that by default, if you ask for 8 cores on the system, it could be that actually lands on 8 different nodes or 8 different computers across the network. But it could be that your code can't cope with communicating between them. So actually it just ends up running on one core on one node, even though you've asked for 8. So understanding that distinction is it's a bit subtle if you're not used to HPC systems, but is an important one. Okay, so accessing and using BlueBEAR. So hopefully you are all now logged in. So we touched on this registration process earlier, but the information is on the intranet. You will need an SSH client, secure shell, that stands for. So PuTTY on Windows systems, or if you're using a more recent version of Windows, you can use the Windows subsystem for Linux. I can never remember which way those second words go around. Windows subsystem for Linux, which is essentially a more sort of familiar terminal type environment. Or if you're on a macOS or Linux desktop system, then you can use the kind of built-in terminal, and there are various different terminal applications that one can use. You can only access BlueBEAR whilst either present at the university or, as most people are at the moment, accessing via the remote service, so via the VPN. So there's both the student VPN and the staff VPN available, both of which can access BlueBEAR, and use your normal university username in lowercase, as I mentioned previously, and your password. Okay, does anyone have any questions before we move on to loading applications? In which case, I'm going to clear my screen. Apologies, as I sometimes I have a sort of nervous tick of clearing my screen when I don't always mean to, or if I think that I don't need to see the information. If I clear my screen, when I say clear my screen, I mean clear all the previous text from my terminal. If I do that and you're in the middle of reading something, then let me know and I'll regenerate it so that you can see it. But I will try to always say when I'm clearing my screen, and I will try to always do it by typing clear as well, because that makes me think about it a bit more. Okay. So applications on an HPC use this idea of a module or an environment module. So the way this works is that you essentially, it allows HPC systems to have multiple versions of software, multiple software applications and multiple versions of those software applications that don't interfere with each other. So when you build software, depending on the software and depending on the complexity of the software, it can have various other dependencies that are required in order for that software to run. And on an HPC system, that can cause problems if you don't kind of manage those dependency trees, essentially. So if, say, MATLAB requires another module in order to run, you need to make sure that it gets the correct version of that module, otherwise you will start to get problems with your code. Luckily, by providing the module system, you don't have to worry about that. So the module system takes care of that under the hood. The only time that may sort of some vague knowledge of kind of how module systems works is if you try and load modules from different versions. So if you try and kind of pull in something that was, say, built against a particular compiler, and then you try and pull in a different application that was built against an earlier version of that compiler, you will start to see clashes. And at that point, you will start to receive errors from the module system to say that this is not compatible with this. This module doesn't talk to this module. So do pay attention if you start to see those errors, because it means that your module choices will need slightly rethinking. And in some cases, it may be that you have to request the installation of an updated version of the module that's compatible with the kind of that tree. But for now, we will choose a relatively simple example. So we will going to load MATLAB, which is a fairly popular application that people use on the HPC system. So the way you load a module is module load, or the command and the verb. MATLAB in uppercase, so it is case sensitive. Module names are case sensitive. Slash or oblique, and then the version that you're loading. And then you will see the output from that will be the list of the modules that are loaded in order to load MATLAB. And you can see that MATLAB depends on Java. So that's a relatively small dependency tree. In particular, some bioinformatics softwares have dependency trees that are about 40 modules long before you actually get to the module that you want. So there you can see the kind of the power of the necessity of having a module system that manages this. If you want to see what modules you currently have loaded, the command and verb module list. So everything up to 13 is loaded by default, suggested by bare default. So that just pulls in all the various kind of environment variables, the pointers for things like license servers, etc., that are required to run. If those modules aren't loaded, then you will not be able to load other modules, or you may run into strange difficulties. So to mitigate that, if you are changing modules, or actually as a good practice, if you're loading a new module, or at the top of every single submission script, we suggest that you put these two following commands. So one is module purge, which will remove all your modules. If I now type module list, I have nothing. Followed by module load BlueBEAR, and that will then get you back to your standard set of modules and run a couple of other commands which do things like tell you what OS you're running on, etc. And if I again type module list, I'm back to that standard set of modules, but without the MATLAB ones. So then I'd have to again load my MATLAB module, at which point I then have access to the MATLAB command. Can't actually remember if this option works to tell me what version it is. Possibly not. That's possibly going to load MATLAB, which is slightly annoying. I will quit out of that. Yes, and I also can't load MATLAB on a login node because it won't let me, because the license server will not talk to login nodes to discourage login node usage or resource overusage. If I just sort of backpedal slightly, and again, if I module purge and module load BlueBEAR again, this time not loading the MATLAB module, and try to type the MATLAB command, I will see this error. So generally speaking, if you get a command not found, it probably means that you haven't loaded the correct module first in order to make that command available in the system. So all the software is there, it's all installed floating, but you just need to tell the system kind of where to find it, essentially. So storage. Storage is available on all the nodes. So all the nodes have access to the same, broadly speaking, the same set of storage. So the majority of the storage on BlueBEAR is network-based. So the RDS, the research data store, is a network store, and that hosts both the project storage, so storage attached to your BEAR projects, and also your home directory. So your home directory is available in RDS homes. If I type PWD now, which stands for print working directory, I will see that my home directory is there. So /RDS/homes/. beginning first letter of your username followed by your username. So that's the standard position. If you're not familiar with Linux, you can get to your home directory by either typing cd with no argument, so change directory, or using the placeholder for your home directory, which is the tilde symbol. And that is why when you log into BlueBEAR, you will likely see the tilde symbol as your current directory that you're in. So it is small. It's only 20 gigabytes, your home directory, and it will never be increased. The reason for that being that we don't expect you to really store a great deal in there. So the majority of your kind of code and your scripts, etc., should all be stored in an associated RDS project space. Your home directory is purely for kind of settings, SSH keys, some configuration files that kind of describe kind of how you interact with the BlueBEAR terminal. But beyond that, the majority of your the majority of your files should be stored in your project space. So all data, job scripts, etc., and output. And you can request, when creating a BEAR project, for up to 3 terabytes of RDS storage per project. So it's quite beefy, and you can exceed that. There is a cost involved, which I think is around £100 per terabyte for 5 years. It might be a little bit more than that now, but it's in that kind of that ballpark. But 3 terabytes for sort of the majority of cases is sufficient. You can start with less and you can increase it over time. It's quite easy to adjust the storage associated with the BEAR project via the service desk. And as I said, so that is available on all the nodes, whether you're on a compute node or a login node, that storage is available across the system. There are other ways to access the RDS. I won't go into the full set of details now, but essentially they are described on this intranet page, so intranet.bham.ac.uk/how-to-RDS. Will give you various different options for mounting it on your Windows desktop, mounting it on your Mac OS desktop, accessing it via BlueBEAR itself. A very useful resource that I will point you at just now is BEAR admin. So if I just shuffle over to this screen here, so bearadmin.bham.ac.uk. You log in with a kind of standard single sign-on, which you should all be fairly familiar with now across the university. Once you're logged in, you will have access to the BEAR identity database, which is essentially where all of the information about projects is stored. And if I just scroll down on my username, so first of all, I get my home directory, so it shows me how to access my home directory on BlueBEAR itself, so the BEAR Linux path. But it also shows me the 2 links if I want to mount it on a Windows system or on a Mac OS system, and you can copy it from there. So likewise with every other project, so if I find a project that I'm a PI on, so here my Carpenter JJ BEAR apps project, I can see it has 2 facilities, BlueBEAR, and it also has 1 terabyte of storage. If I click into that project and then scroll down, so lots of project information, I get the similar stuff, the similar links here. So again, if you need to access this anywhere other than BlueBEAR, then you can use these links for mounting it. The macOS path mount, by the way, works on Linux, or the majority of Linux desktop systems as well. So that's BEAR admin. We will come back to that in a little bit because it contains other useful information that you may want to access. Oops. Okay. Does anyone have any questions about storage or applications or anything that I've covered so far? I realize there's quite a lot of information. This course is heavily front loaded. So if I've skipped over anything or you want me to go into more detail on anything, just shout at any point. That's absolutely fine. Okay, and Debbie will. There is chat conversation going on. You can ask questions in the chat. If the same question keeps coming up, then Debbie may escalate that up, and we can discuss it as part of the course as well. So how to write a job script. So we're actually going to talk now about actually running jobs on BlueBEAR. So far we've been doing everything essentially interactively via the terminal. Now we'll kind of take the next step to packaging that all up so that you can then submit it to the scheduler. So we'll talk about the job script. We'll talk about the limits, how to choose a QoS, the options that you need to provide depending on whether you're asking for a multi-core on a single node or multiple nodes, and then we'll look at some job scripts. So let me just create a new directory. So intro, May 2021. just going to move this over slightly so I don't keep folding lines. So I'm already going back on what I previously said, which is that you should, the majority of the time, store this sort of data in your project storage area. I am temporarily creating a directory in my home directory, but generally speaking, this will be stored in your projects directory. And that's where that's located. So I'm going to create all of the scripts that I require to run this job from this directory. So when you so backtracking very slightly. So I'm going to create a file called a job, or a shell script called job.sh, which is, so .sh is the standard extension for shell scripts, although be aware that as far as a terminal is concerned, it doesn't have any sort of knowledge. It's not like a kind of a Windows or a Mac system that gathers some information from the extension that a file has. As far as the terminal is concerned, every file is equal, broadly speaking. So it actually doesn't pay any attention, but just as a kind of, in terms of your own usage of the system, it's a good idea to use some of these kind of standard methods. So .sh is the shortcut for a shell script. And I'm going to use the editor Nano. So there are various editors. My personal preference is Vim, but if you're not familiar with command line or terminal-based editors, then Vim is probably not the one to start with, mainly because it's very difficult to exit from. If at any point you find yourself stuck in Vim, do give me a shout, and I will help to get you out again. But for now, I'll use Nano. So Nano looks like this. So a useful kind of blank slate, and crucially, it provides you with some information about how to actually use Nano, which Vim doesn't. So that's why it's preferred for kind of if you're not familiar with terminal-based editors. So this is where we will be creating the job script. And when you start passing commands to your script that you then submit to the scheduler, they will be in this format here. So every line that starts with #sbatch or #sbatch is passed on to the scheduler. And as we progress, that will become a bit clearer. So why does it keep going backwards? I'm clicking the wrong side of my mouse. Here we go. So your job script should begin with a header, or the standard shebang line. So we want to run this as a bash script. So we need to tell the scheduler will need a shebang line, otherwise it will throw an error and your job won't run. So it needs to start with some kind of shebang line. Other shebang lines are available, but all of the examples we provide, and generally speaking, we suggest that you use bash. And then your sbatch headers. So every line, like I said, that begins with # or asterisk sbatch is where you then provide an option which is interpreted by the scheduler. So for example, -- time, 5 is asking for a job that will have a maximum wall time of 5 minutes. There are other ways of specifying these options. You can use the shorthand version, which is -t5. However, I have a sort of general practice when writing scripts that I will always use the long version of an option. So if you're familiar with command line sort of working and running commands, you will find that most programs have a short and a long option. Certainly for kind of the most frequently used options or arguments that you'll pass to a command, there will be a way of specifying it as a single letter, normally with kind of this, a single sort of dash before it, or a double dash and then a longer version. When running anything in the script, I will always use a longer version because it's more explicit, simply for the version that I don't really need to type it quickly every time, and it just makes it clear if I come back to this script in a year what that is referring to, because -t will mean various different things for various different commands. So it's just a little bit more helpful. So your various sbatch headers, you will probably have more than one, but for the purposes of this bit of the course, we will just stick with the time one. And then your standard commands, which are module purge, followed by module load BlueBEAR. So this is the one that resets your environment. And this is really important because if you don't do this, you may find that bits of your environment that existed when you submitted the job get inherited by your job and then cause unexplained behavior or unexplainable behavior. And it'll be because the path is slightly confused, or it's trying to load a version of Python that was compiled for a different type of node or something like that. So essentially you can get nastiness. To avoid the nastiness, module purge, module load, BlueBEAR at the top of every script. Essentially the semicolon is the same as doing that, just running them on two separate lines. If you prefer concise scripting, then the semicolon is your friend. And then once I've done that, you then load the modules that you require. So in this case, we're going to module load Python, and we're going to get version 3.8.2, built again GCC core 9.3.0. Now, you don't have to remember, and actually I very rarely type any of these module names. You should use instead our BEAR applications website. So bear-apps.bham.ac.uk. And actually Python is always a terrible example, because if I type in Python, most stuff, well, many applications have Python kind of as part of their module name. So I'm going to go this route, so the more advanced search option, which should return fewer. There we go. So if I click into the application name here, so I can either go into the specific version of the application or more general information about that application, at which point it then gives me a list of all the versions of that application I have installed. So the one that we're loading, I believe, is 3.8.2, which is built against GCC core 9.3.0. You don't really need to know that. The key bit you're looking for is the version of Python, which is at the beginning of that string. If I click into that, you then get that module load command. So wherever possible, when working in the terminal, copy and paste is my recommendation, because if there's a slight kind of a character out of place, or you've got a capital C when you should have had lowercase c in GCC core, the module will fail to load. So copying and pasting wherever possible. So I'm actually going to delete that. I think I typed it correctly, but complete confidence. There we go. So module load Python, and then the commands that you're passing to that module. In this case, a standard command. So I'm going to pass the command print hello world to Python, and then that's my script done, and it will exit. So that is the kind of bare bones of what a script would look like. What I tend to do is sort of cluster bits of my script together. So if I have a bunch of SBatch options, I'll have them all in a chunk at the top here. Oh, I can type SBatch. And then a space, and then I have the sort of, what I determine is the sort of boilerplate code where you do the module purge and module load BlueBEAR. And then probably I'll have another couple of lines, my module load commands to keep those all together, and then the list of commands that I actually want to pass. So again, it just, at a glance, it makes it easier to kind of see kind of what's the header stuff, what's your kind of boilerplate code, where are you loading your modules, and what are your commands. It just makes it a bit easier if you have to debug in the future. And then I will save that. So in Nano, the way you save is Control and O. That works on both macOS and Windows systems. And then it gives you the information that it's written out those lines. So if I now exit Nano, type ls to list the contents of that directory, I now have my job.shut script. I will go back into. So there are limits. BlueBEAR is not an infinitely resourced system, but it has a reasonable chunk. So per user, per shared QoS. So by shared QoS, I mean that QoSs that are not owned by a particular group. So I mentioned earlier that you can sort of purchase preferential access by actually buying some resource on BlueBEAR. So that sits slightly outside of this model. But in the majority of cases, you'll be using the shared QoS. So the total sort of cores that you can request is 320. So that can be in a single job, or that can be in a bunch of jobs, and up to 3 terabytes of RAM. And that will be distributed memory across the HPC system. That won't be on a single node, because we don't have any nodes that have up to 3 terabytes. We've got nodes that have around 1 terabyte, but not quite up to 3 yet, I don't believe. I may be corrected. And The biggest job that you can request in terms of RAM is 498 gigabytes. Again, that's in a standard QoS. There are other options available if you do require more RAM on a single node for that job. For the majority of users, the maximum wall time for a job is 10 days. If you are working in life sciences and have access to any castles resource, then that is up to 30 days. And I will touch on how you specify some of those different options in a moment. Just sort of touching on running jobs in multi-core. So obviously a benefit of an HPC system is that you have access to multiple cores on both a single node and spread across the entire system. So you can have up to 320 across the system. However, it's really important to note, and I did sort of mention this briefly earlier, that not all jobs necessarily can handle multiple cores. Either they can't handle multiple cores on a single node, or they can't handle multiple cores across sort of internodal communications. So it's good to know what you're running and sort of what your applications can handle. So not all jobs scale well over multiple cores. So always, when you're experimenting to begin with, run some short runs on kind of a subset of your data to try and determine kind of where the sweet spot is between asking for lots of resource and running your job for a little bit longer. You will find when you start to kind of use the scheduler system more, there's quite a lot of nuance around kind of how you specify your resource requirements, depending on how busy the HPC is. So if you're asking for 300 cores and you want it for 10 days, you're probably going to be waiting for quite a long time for that resource to become available. However, if you can carve your job up into smaller chunks and run those kind of in for smaller run times with fewer cores, then that may be sort of beneficial. And it entirely depends on workflow and the type of applications you're using.
James?
Yes.
Can I interrupt and just ask a quick question? If
Sure.
we're using somebody else's software, is there one thing we can look for to know whether it would scale over multiple cores or not?
Yes, I will touch on that in a second.
Okay.
I think it's on the next slide, but if it's still any clarity required, then do shout out. So, like I mentioned, the more cores you request, the longer you're likely to wait for your job to start. And just requesting lots of cores doesn't mean your software can use them. So, I mean, that's a really important distinction. I know I'm reiterating it several times, but just throwing 300 cores at a job that essentially can only use one core is not going to give you any sort of speed up at all. And so a good example is Stata, so a statistical software application. And there is if I make that slightly larger. So as you can see from the convenient graph here, in an ideal world, if you provide 8 times the number of cores, you should get an 8 times speed up. But as you can see, that's not the case with all types of job. So I mean, logistic regression gives you kind of a near linear response, not quite, but different types of commands will run sort of more or less efficiently. So 1.6 times faster on 2 cores, 2.1 times faster on 4 cores, and 2.7 times faster on 8 cores. So the amount of time you will wait for those 8 cores to become available versus waiting for 4 cores to become available probably isn't worth it for that 0.6 times speed up. So I mean, this is where it very much depends on the types of workflows you're running, and it's to do with various overheads. So there are overheads involved in, particularly with internodal communications, where you're having to pass information between nodes. There are overheads in terms of accessing memory and also accessing storage. So these are the reasons why you don't necessarily get that linear speed up. I'll shrink that back over a little bit. So I mentioned QoS before. I will come back to multi-nodes and parallelism in a second. So by default, when you add the BlueBEAR facility to a BEAR project, you get BB default and BB short. So BB default, as the name suggests, if you don't specify a QoS for your job, you will get assigned BB default. If I head back over to my terminal here, so the way I specify QoS is like this. By default. Still trying to spell default. That's how you specify the QoS. Like I say, actually, that's a redundant line because BB default will be used if I don't specify otherwise. And the other one that you get as standard is BB short. BB short is my favorite QoS because it allows access very quickly to very large amounts of resource, so long as the job that you're running has a wall time of 10 minutes or less. And depending on types of workflows you're doing, that can be very useful, and it's generally sort of an underused QoS, although I think it's becoming more popular. But particularly if you're doing array jobs, which I'll touch on in a little bit, BB Short is most certainly your friend, because you can crunch a lot of data very quickly if you're using that resource. So you can get access to 300 cores like in a few minutes. Generally speaking, I found, I haven't tested it today, so it may be different today depending on the business of BlueBEAR, but generally speaking, BB Short gives you that access quickly, as long as your job doesn't require any more than 10 minutes to run. There are additional QoSs that are available to add to your projects. So again, in the same way as you add the BlueBEAR facility to a project, you can then kind of append different QoSs to that project. So BB Large Mem is one, so that allows you to access a couple of the nodes that have more system memory, so up to 498 gigs. Please note that if you have access to castles, again, some of the castles nodes have access to up to 1 terabyte of memory already, and you don't need to use the additional BB Large Mem QoS. And also BB GPU, so that allows access to nodes that have general purpose GPUs on board. So for machine learning type workflows is a kind of classic example of where you might use a GPU, but various other software applications can utilize them. Again, knowing your software and knowing that it can handle the use of a GPU is required. Otherwise, you may wait a long time for GPU resource because it's relatively scarce. And as I mentioned before, you specify your QoS by providing sbatch -- QoS, and then BB default, BB short, etc. So on BB default, is made of different types of node. So the majority at the moment is a 20-core node with 120 gigs of RAM. Slightly behind that in numbers is a 40-core node with 180 gigabytes of RAM. So that's the Cascade Lake type of node. So essentially, these nodes are different generations of Intel CPUs. And we are soon to be bringing online a newer one, and I've completely forgotten the name of it off the top of my head. It's not Coffee Lake. It's I don't think it's
Ice Lake.
Is it Ice Lake? I think it might not. I think it's the one beyond that, and I've completely forgotten it. Ryan, can you remember which model?
No.
There is a new. Watch this space. There will be a new type of node coming online soon. And then we've got a few of the 24-core nodes with 128 gigs of RAM. So essentially in order, that's the Haswell node type, followed by the Cascade Lake node type, followed by the Broadwell node type. As we bring on, as I mentioned earlier, BlueBEAR is a rolling HPC system. So as we bring on the new node type, we will start to retire some of the older nodes as they reach end of life, which is generally 5 years. So this makeup sort of will always change over time, but as far as I'm aware, this is currently correct. So BB Short, I mentioned before, contains all the nodes. It's a way of getting your job to run very quickly, but it has a maximum 10-minute wall time. BB Large Mem contains access to a greater amount of memory. The specification is slightly different when you're asking for memory for a large node, and I'll come back to that in a minute actually, because there's an important distinction between two memory type options that you can pass to Slurm. But like I say, you don't get this by default, so you have to request for this to be added to a project. And likewise, BB GPU. Actually, I will just go back to Large Mem, just touch on these memory options. So the long option, as written, for asking for number of cores is --n tasks. So this is sort of, again, Slurm parlance. Tasks equal cores, which in our sense broadly equal CPUs. There are subtle distinctions between them. And if you come from different HPC systems that also have used Slurm, the Slurm scheduler, you may find that the way that we use those terms differ slightly. But generally speaking, cores, tasks, and CPUs are synonymous, at least on BlueBEAR. But n tasks is the option. The short option is -n. So for number of tasks, which I actually, in this sense, I actually prefer because I think it's a little bit clearer. N tasks always seems like a bit of a misnomer. And then you provide the number. So that's asking for 4 cores, essentially. Note that because I haven't asked for those 4 cores to be on a single node, they could be scattered across multiple nodes, potentially. So when you ask for a core on BlueBEAR, so the default is 1 core, so if you don't specify a number of tasks, you will get a single core. You are automatically assigned an amount of RAM for that core, and the amount of RAM you're assigned is just over 4 gigabytes. So you get about 4 gigabytes of RAM per core. Generally speaking, we suggest that people they don't actually override that. You can override that. We suggest that you don't, because it allows BlueBEAR to be efficiently resourced, because it carves up the nodes. So we know that, say, the 40 core node that I mentioned has 180 gigabytes of RAM. With various system overheads, 4 gigabytes per task is a good number for that. So it allows you to sort of stack multiple jobs onto a single node without running out of RAM or running out of cores. If you do occasionally need to override that, then the option is --mem per CPU. So then I can adjust the amount of memory that is assigned per task. Now this is quite different from this option. I'm going to write them next to each other, but you'd never see them next to each other because they essentially override. I don't know which one takes precedence, so I won't hazard a guess. --mem, which is the option you see down here, will request an amount of memory for each node on which your job is running. So whereas here with my N tasks and mem per CPU, so I'll get rid of that because we don't actually need to provide it. If those 4 tasks get assigned across 2 nodes, for example, one of which has 1 core running on it and one of which has 3, then that carves up the memory proportionally. So I'll then get the node that has the 1 task running will get 4 gigabytes, and the node that has 3 tasks running will get 12 gigabytes of RAM. So it ensures that you get kind of, so again, efficient kind of stacking and usage across the system. If I say ask for 200 gigabytes of RAM, but use the --mem option, every node on which my job gets assigned will request 200 gigabytes of RAM. And that becomes a problem if you've asked for, say, 30 tasks, 30 cores, and they happen to get assigned across 30 nodes. You're then waiting for 30 nodes to have 200 gigabytes of RAM each available before your job will run. And you'll be waiting a very long time for that to happen. 200 gigabytes is not a particularly good example in this case because that exceeds what the kind of maximum for the majority of nodes is, but you get the idea. So essentially, --mem is important for certain cases if you're using a large memory node, but should not be used kind of for general job submission, because it can essentially mean that your job waits a very long time and BlueBEAR's not being efficiently resourced, because you could essentially occupy all the memory for a node, but you're only using 1 core out of a 40 core node, but nobody else can essentially then use that node because you've eaten up all the RAM. So an important distinction between those 2 options. If you are running large mem jobs, then you should also provide this option, which I think is documented on the website. For some reason, I've missed it off this particular slide, but --nodes1. So that says that I want my job to run. So let's get rid of these confusing, contradictory instructions. So this is now requested that my job will only run on a single node. So I'm guaranteed by using this specification that my 4 tasks or my 4 cores will all be on 1 node. And then on that node, I need 200 gigabytes of RAM. So this makes more sense, particularly when you're using the large mem resource, because there are only a handful of large memory nodes. So memory is always a little bit fiddly, but if you understand the distinction between mem per CPU and mem, and also specifying a single node versus multiple nodes, then you should be well placed. But essentially, if you find that your job is sitting for a very long time queuing, and it's difficult to determine what a very long time is because it varies hugely from day to day depending on how busy BlueBEAR is, but it might be worth looking at your memory specifications, and there are other ways of kind of determining exactly what resource you've requested, which we will touch on in a minute when we actually submit a job. So proceed. Touch on BBGPU. So again, I won't go into this in too much detail because we won't submit a GPU job now, but you do require, if you're asking for a GPU as well as submitting to the BBGPU QoS, you have to ask for a GPU, and this uses the Slurm GRES, which stands for generic reservation option, and then you say, I want a GPU. You can optionally specify the type of GPU, so P100 is a type of NVIDIA GPU. We also have V100s, and we'll soon have A100s, excitingly. And then the final number in that string is the number of GPUs you're asking for. But more documentation on that is available on the website. So to come back to the question that was asked earlier, so there are different types of multi-core jobs. One which needs to be on a single node, so that's multi-processing. And another type which can span multiple nodes, so that needs to be able to therefore cope with the fiber interconnect. So what you're looking for, certainly in open source software, is these two terms. So OpenMP is the kind of standard library that is used for parallelization on a single node, versus OpenMPI, which stands for Message Passing Interface, which is used for parallelization across multiple nodes. So when you're looking kind of for your software, you need to see that it's using those systems. So generally speaking, you will see some reference to OpenMPI if your software is capable of doing sort of internodal communications. So hopefully that touches on the question that was asked earlier. Again, this option here comes up. So if your software cannot cope with spanning multiple nodes, which is a large amount of software, then making sure that you specify this minus nodes one option is good. You can either provide it just as a single number. I think in older versions of Slurm, you had to provide 1-1, which was the minimum and maximum value, because the number that you provided used to be the minimum number of nodes that you were asking for, which didn't quite make sense. Now I believe that's the maximum number of nodes that your job can be assigned. But so yes, so you don't need that slightly longer format, but it won't hurt. Note, I've touched on this already, array jobs may be better in some cases. So array jobs is where you can throw a very large number of the same type of job at Slurm, and Slurm will scatter it across the system. The jobs won't be sort of parallelized in themselves, but they will run, it will allow you to kind of to process large amounts of data simultaneously. So they may be better, and you will likely wait for less time than if you're asking for a single job that requires multiple nodes across the system. Okay, let's come back to an example job. So I'm just going to tweak my script here. So I've got my module purge, my module load BlueBEAR commands already. I'm going to ask for a single task. I'm going to put it on BB short. If it actually runs, I'm definitely going to get rid of that. So I'm just going to use the standard memory assignment, so I don't need to specify memory. I'm just asking for one task, so I don't actually need to ask for it to be on a single node, because a single task can only be on a single node. And I will add mail type all. So this is just what communications I get from the scheduler. So this means that when I submit my job, it will tell me, I'll get an email when my job is submitted, an email when my job runs, and an email when my job completes. There are various different options to this, such as fail or end, I think. I can never remember the precise terms, but the documentation, the Slurm documentation is the best for this. So if you search for the SBatch documentation in Google, it will tell you all the different options that you can provide to that. For now, we'll stick with all. Generally speaking, you just want to know when your job finishes or it fails. Set -e is a very useful thing to include in all your scripts. If ever you write any kind of shell script, use set -e. What set -e does is it ensures that if any of the commands within your script fail, the entire script fails. And that's really quite handy, because what you don't want, for example, is, say, the beginning of your job, you copy a bunch of content from one directory to another, and then subsequent sort of commands then process that moved data. So it's a simple example, but not an uncommon one. If for some reason that copy operation at the top of your job fails, then you want your job to exit out. What you don't want is for your job to then continue on trying to process data that is either old, so outdated data, or just doesn't exist, and then you'll start to kind of get strange errors. In that case, it should be pretty clear. It should say directory not found or something like that. But there are examples where you can get some very strange behavior that's very tricky to debug, purely because some step in your script hasn't completed, but your script's just carried on. So to stop that from happening, set -e in your script will ensure that the whole script fails out if any kind of command within that script dies. And then, so in the case of our Python example, we'll do this. So that's our job.shut. Have I got that correct? Yes. I'll find out when I submit it and it's wrong. So I will also create my hello.py script. So again, nano. So hello.py. If you aren't familiar, .py is the kind of standard extension for a Python script. I don't need a shebang, so I'm going to call it from Python itself. I don't know why I made this script so long. At some point, I will actually put the script onto the website so that it can be copied and pasted. So this is essentially an extremely dull script that that finds out what node it's running on, grabs the time, says hello at this time from this node, and then says ta-ra, essentially. Sleep for 3 seconds. Timestamp 2. You can see how atrocious my typing is as well. If anyone spots any glaring errors that I'm putting in the script, then do feel free to shout at me. Although if you are a Python user and you don't already use it, I would strongly recommend, assuming you're using Python 3, of course, that you start to use this newish string formatting, because it's very nice. Okay. Second more time, so I can get how it's now. That looks believable. I'll find out when I try to submit it. Okay, so I have my script, my Python script, I should say, that I want to run, and I have my batch script that tells the scheduler how to run it. And then the final step is actually submitting it to the scheduler, and that is done using the command sbatch. So sbatch is available on all of BlueBEAR's nodes. As has happened occasionally in the past, if you find that sbatch doesn't exist, it probably means that you're on a VM. I know that because I think the Intro to Linux course uses the VM rather than using BlueBEAR. And I know in the past, a couple of people have not been able to run the sbatch command because they've actually been logged onto the VM rather than onto BlueBEAR. So make sure that you are on BlueBEAR. The way to tell is that you should be on a node or on a login node that looks like that, BBPG login 1, 2, or 3. If you're not, then log out and log on to BlueBEAR. And then to submit the actual script, so sbatch is the command, and then you just provide it with the file name or the script and hit return. And all being well, you will get something that looks like that. So submitted batch job gives you an index for the job. And that's now gone off to the scheduler. And I haven't got Outlook open, but I will have received an email to say that that job is off. And there are various ways to query that job, and I probably have missed them because that job runs very quickly. So SQ will show me my running jobs. Aha, it's still just about that. I'm just going to make this slightly bigger, and I'm going to very slightly shrink the text. Hopefully I won't make it so small that nobody can read it. I will make it bigger again in a minute, but if you find that illegible, then do shout out. But I'm going to run, so SQ again. It may have disappeared now. No, it's still there. Oh, it's pending. Yeah, okay. So that's sort of convenient, but sort of annoying at the same time, because I would have expected it to run now. I know that BlueBEAR was very busy yesterday, so we may be in a position that all the jobs that we submit don't actually run. Hopefully that won't happen, because that would be somewhat irritating. But it allows me to get through these without the job getting sort of wiped out. So SQ will show you the jobs that you have running or pending. It will briefly show you jobs that have completed, but only for about 30 seconds, and then they fall off the queue. So SQ will pretty much show you what you've got running at a given time. There's a variation on SQ, which is show queue, which is actually a wrapper from the previous scheduler that we used to use, but it provides information in a slightly different format, which in some ways is a little bit clearer. So rather than PD, it actually says pending. You can drill into the job a little bit more by using S-control. So S-control show job, and then provide the index for that job. And that gives you much more information. But the bit that I find really helpful with S-control is this chunk in the middle here, particularly if you're sort of playing with kind of memory resource requests to see what's actually been asked. So this line here tells you exactly what your Slurm specification, so your SBatch head, is what you've actually asked for and what you've been given. It's quite handy. So it tells you how much mem I've got in total. It tells me how many CPUs I've got, how many nodes I'm running on. You can ignore billing. And then a bit more information, so it will actually tell me once my job is running, it will tell me where on the system it's running, which node that is. And it also tells me what my paths for my various output files are. So Slurm will give me some information about its running state when it's doing it. However, it doesn't appear to be running yet, which is slightly concerning. So we may have to do the rest of this course. All right, is that done? Has that gone? Yes, it has. Phew. So scratch what I was saying earlier about BB Short being an extremely fast queue. It appears today is one of its off days. So at least it's running, which is good. So you should all be able to get some output. So that gives you an overview of kind of how to query your running job. If you have accidentally submitted a job and it's going to take sort of 10 days and you realize that actually you don't want it to run, then S-cancel is your friend. So that will just cancel out the job that you've got. So again, S-cancel, and you just provide the job index. So you pull the job index from running SQ, which should hopefully now be empty. Oh no, it's still there. It's still cancelling. It's just being a bit, maybe the database is being a bit slow today. So I can S-cancel, but CG means it's essentially completing. So when your job runs, it will create two files. It will create one called slurm-your-jobindex.out and your .stats files. So we generally, if you ever open a ticket with BlueBEAR, with advanced research computing, we will often ask you to provide your out or stats files for a job, because that allows us to just see a bit more information. So I'll start with a .stats file. So let's have a look. I'll just cat it for now. So just print it to the terminal. I will clear my screen first because it's got a little bit messy. I'm also going to move the Zoom banner, which is in my way. There it goes. So it's a little bit like S-control in that it gives you that little bit more information about your job. So it's created as soon as your job starts running, you will get your stats file, but it will not be completed until your job has completed for obvious reasons. However, when your job completes, this section is super useful because it tells me that my job completed correctly. So an exit code of 0 is what we're looking for. An exit code of anything other than 0 is generally an error. So hopefully we've finished with an exit code of 0. It tells me kind of how it completed, but more interestingly, it tells me how much time it took. So it tells me it took exactly 23 seconds. So what I was saying before about running smaller jobs and then kind of using that to kind of inform how you need to scale them as you kind of increase your data set or whatever, then that's useful information. But even more useful is this bit of here, which tells you how much memory it actually used. So my job, because it used the standard assignment, I got 4 gigabytes of memory for my one requested core. However, my little Python script only used just over a meg of memory. So this is really handy because it allows you to kind of troubleshoot or sort of refine your resource requests if you need to. So if you think your job needs vast amounts of memory, always check your stat script to see what your job actually used, because it may be that it's not a particularly memory bound job, it's more of a CPU bound job, and you can get an indication of that from this information, and also the CPU time, which is the amount of time the CPU is working on your job, as opposed to the amount of real time, which is how long the actual job took. So your stats file is very useful. The other one is the slurm.out file. So the slurm.out file is essentially what you would have seen had you run these commands by typing them into a terminal. So if I'm working in a terminal, I type Python hello py, it prints some output. That's what I'll see. If I type ls to list my directory, it prints some output. That is what I would see. So the slurm output file is exactly what you would be seeing. So in my case, I loaded Python, so I got that's all the stuff that was brought in as part of that module load command. So I mentioned before that you get a list of all the dependencies, and then this is my Python script actually running. So it said hello from the node that it ran on at that time, and then bye bye from the same node at that time. So that's my Python script actually running, and then it exited. So in a nutshell, that is what a job looks like. Obviously, that's a very dull job. Your jobs will hopefully be more informative than this one, but it should give you an indication of how that works. So now it is your opportunity. What's the time? 11:15. Good. So if you have a play with essentially running the commands that we've just been working on, I will go back to the previous slide. Actually, I'll tell you what. I will bring up. What's the best way to do this? I will bring it up in the terminal here. So if I go, oops. There are better ways of doing this, but this is for speed. So there are the two scripts so that you can copy the information from them. So 20 minutes now to have a play with that, to ask any questions. Have a break, obviously have some coffee if you so wish. Try running the Python, try playing with the kind of the SQ, show queue options, looking at the output that's created, try tweaking the options to see how that output changes. If you're not familiar with it, the command tail is your friend. So as soon as your job starts running, that slurm out file will be created. And as your job continues, it will be appended to. So by saying slurm, actually, if I just back out of this for a second, I can go tail -f on my slurm.out file. And as that out file is updated in real time, tail will follow. So -f means follow. So it will follow the output as it's appended to that file. So it will effectively be like watching it in real time, but it allows you to dip in and out of it without the job actually being affected. So it's convenient. So yes, have a play with those two scripts now. I'll get that job back up.
Can I ask a quick question?
Yes, of course.
So I'm a bit, I didn't get it exactly when we should make the directory. So when we submit the job is from our project.
If you know that someone's not here for some reason, then shout. But I'll carry on otherwise. So let me just exit out of this for now. Exit. Put that a bit of space back there. Let's clear that screen. Okay, so hopefully you all managed to get something running, and you also managed to take a break. So we'll continue. So that's the kind of the crux of what you'll be doing on BlueBEAR, is once you've kind of got past the stage of where output is directed to, kind of where you need to be, the idea of kind of your working directory as a concept, so that Slurm understands where you submitted the job from is where it will output its file to. Things like that are all kind of useful concepts to get you started. we'll now just go on to kind of a few other options, look at some other ways of working with Slurm, and also other ways of kind of accessing BlueBEAR. So we spoke about primarily this is kind of looking at batch workflows, but there are other options, including BlueBEAR Portal, which we'll touch on in a moment. So I talked about Bear apps before, just to kind of show you again. So if I go back to the top level of this, so we know that at the top, on the top page, you just get a list of the recent applications that we've installed and the versions of those applications. You can look sort of into a given application. So if we go to, actually that's a really bad example because there are very few. IPython, for example, we have many different versions installed over the years. The module names are long in a lot of cases, and that's because of the way that we build the software. So I mentioned briefly before that if we build a version of Python, we'll build it with a particular version of, say, the GCC compiler. And then 6 months later, we will build a slightly newer version of Python, which we'll build against a slightly newer version of the compiler. And then we will also build a bunch of other applications also against that version of the compiler, and they will all be able to sort of to work in combination. Applications that were built with different compilers will not work with each other and can cause errors. And the way that you can sort of determine this, and it's slightly obscure, and I apologize for that, is essentially the string that is appended to the version. So what you will get with the module names is the name of the module first with a // the version, so that's the developer's kind of versioning scheme that they use, followed by a hyphen, and then a kind of a string that represents how it was built and against what it was built. So in the case of Python here, the string is GCC core. Can people see my screen actually? It's lost. It did have a little highlighting ring around it, and it's gone. So good, thank you. So here I can see that this version of IPython was built against GCC core 10.2.0, which means it can talk to all other sorts of GCC core things. However, that also means that it can talk to modules that were built against what we call FOSS 2020B. So I won't go into too much detail here, and if you get kind of stuck with it, then come and talk to us. But essentially, every 6 months or so we will release a new what we call toolchain or Bear Apps version. So the current active version of Bear Apps is 2020A. So when you're loading a lot of applications, you will see something like FOSS 2020A, or if you're working with GPU applications, you'll see FOSS CUDA. So CUDA is the NVIDIA libraries that we use to be able to talk to GPUs. So if you're doing anything GPU based, you should be loading some kind of CUDA variant of that module. If you're not working with GPUs, you don't need to have CUDA in the name anyway, so you just load the standard FOSS version. FOSS standing for free and open source software, but essentially it's kind of the open source compilers. With some applications, we compile them against the Intel compilers, because some things like the Intel compilers. So you will see some modules that are named like module name, module version dash Intel or Ioncal, which is where we've got to mixed up the Intel compilers for different things. The crucial thing is that the kind of the suffix to the module name should be the same, generally speaking. There are cases where it's not quite, but generally. And also, if we're building against a clearer way is if you're doing something like loading a Python module, so IPython is actually something that is obviously built on top of Python, and you will see specifically the version of Python that it was built on top of with the kind of the final suffix. And then, like I say, these can go on for quite a long time, particularly where we have some modules that were built against Python, but they also have some R. If you're familiar with R, the kind of the statistical application, then you can get things, the strings with like FOSS 2020A / Python version / R version, and it gets all convoluted, but essentially the key thing is that it matches. So that's the Bear applications pages. But like I say, if you find yourself getting in a pickle with the applications and you want to know what combinations you can use, then come and talk to us. I'll sort of point you at some links later on, because we may be able to advise. We may say, well, actually, in order to do this workflow, you'll need to have this application reinstalled for this particular Bear Apps version, etc., etc. But we'll be able to assist with that as a team. So that's the Bear Apps pages. Like I say, very useful for copying and pasting your module load commands. BlueBEAR Portal is a relatively new service that we sort of we expedited its release this time last year for kind of unsurprising reasons. So this allows you to kind of access more GUI-based applications. So running GUI stuff on HPC systems is generally unpleasant because it has to be done through what's called kind of X11 forwarding, which is where you sort of tunnel the graphics through the SSH connection. But it's slow. I mean, it's faster if you're on campus. But even then, it's never depending on the complexity of the application. It's never going to be the most kind of streamlined experience, and particularly if you try to do any kind of X11 sort of forwarding kind of GUI stuff remotely through the VPN, like you get significant lag. You click on something, 10 seconds later, the menu appears. It's just miserable. So we don't recommend it generally. There are cases where it's necessary, but generally speaking, we suggest that people find a batch-based workflow that kind of replaces the functionality. And there are other ways. I was talking with the user earlier of if you want to kind of develop, say, Python code, you can do that locally on your system by mounting your, say, RDS project folder onto your local desktop. You use your IDE of choice, and then on the login node, you just then submit the job and say, submit this Python file. But it's not a Python file that you then had to edit or do anything with other than just submit it to the cluster. BlueBEAR sort of portal gives us a slightly different kind of approach to that. So we have a bunch of interactive apps. My version will look slightly different because I have the developer stuff here. But generally you will see kind of a list of the applications. So Jupyter Lab, RStudio Server, etc., ANSYS. You won't necessarily be able to see all of these because some of these are license restricted, but there is a kind of standard set like MATLAB, Jupyter, RStudio that I think all users will be able to see, and also Code Server. So Code Server is a useful example. So this, if you are familiar with it, VS Code is a very popular kind of interactive development environment for Python and numerous other languages. It's very extensible. If I click on that, I can start hopefully a job. Although given that things are submitting quite slowly at the moment, I don't know how long this is going to take to go, but I will set it off now and then maybe come back to it in a minute if it's taking a while. But essentially you can ask for amount of resource and number of hours on the system. So I'm just going to ask for 1 hour. I can get rid of that because that's finished. And so you're now essentially, so what this is doing is it's behind the scenes, it's submitting a job via Slurm. So it's asking for the kind of resource in the standard kind of Slurm way, but then it's actually going to give you a link to Code Server running in the browser. So this is where this is much better. So for applications that you would previously have forwarded via X11, this actually does the X11 forwarding, but locally, and then puts it into a web interface, and then you talk to the web interface. But effectively, you're talking to the GUI as if it were on campus, even though you're off campus. So it's much faster and much more responsive. Code Server is even better because it doesn't actually use X11 forwarding. It uses a kind of server client model. So if I click into here, it will open me a new tab, and then I now have hopefully a fully fledged GUI editor that's actually working in the browser. It has access to all of the same content. So by default, it drops you into your home directory, but you can navigate anywhere on the system. I go to open a file. So at the moment it's put me there, but I can backtrack a little bit. Projects, etc., etc. I think mine is still in the old format, so they're lurking in this file somewhere. Carpenter JJ. BEAR apps. And then I can start working on files in this directory. So this can be quite nice for sort of editing stuff that's on BlueBEAR without having to kind of mount it locally. It's much faster for accessing the files. You've got all the features of VS Code, which is a pretty feature-rich editor. But then you've also got the you can either log on to BlueBEAR, or conveniently, if you click on this link, so you go back to your interactive sessions, it tells you what host it's running on. If I click on that host name, it then drops me onto a web-based shell. So I can then essentially do what I was doing before. I can see what services I've got running. So for example, this is what I've got running. So that's my VS Code is running locally on this computer, and I can actually then also use this to submit jobs because I've got SBatch. So I can write my job script, so I can do all of that from here. So actually, I don't have to use PuTTY. I don't have to use my terminal client. I can do it all in a web interface. So there are different kind of different workflows to suit different kind of people's preferences. I will close that now so I don't eat resource. So that's BlueBEAR portal, which I need to rename. It's not Bear portal, it is BlueBEAR portal. I keep meaning to change that. Okay, taking a complete sidestep, coming back into the world of CLI, command line interface, kind of batch processing. So as I said before, the majority of storage that you will be using across BlueBEAR is network-based storage, and that's available across all the nodes. It means that you can have a multi-node job all writing into the same directory and talk and pulling content from kind of other aspects of the job, which is useful. However, network-based storage, even if it's over super fast InfiniBand, is always only going to be as fast as that connectivity, and it's never going to be as fast as something that you've got local on the system. So all of the nodes also have a small amount of locally attached SSD storage. So if you're doing types of workflows that require lots and lots of data I/O, so input output, you probably don't want to be doing that across the network, because if you're reading thousands of files in, doing a tiny bit of modification, then writing them back to the network, that will have quite a big overhead on it. So you'll be pushing that data back and forth across the network all the time. What is a better practice, and it doesn't apply to every situation, but in a lot of situations where you're doing that type of processing of data, is to pull it locally first. So you download it, you get it off the network storage, write it into what we call a scratch location, so a temporary storage location, which is on the node. You do all the data I/O processing there, so that means you've got much faster connectivity between the data and the CPU and the memory. And then when you finish working on it on that node, you then send it back up onto the network storage and save it there. And again, depending on the type of workflow that you're doing, you will see potentially kind of quite significant speed ups. So if you've got a very sort of I/O dependent job, using scratch storage is very useful. There's all of this information is replicated on our website, so I'm not going to go into it in much detail now, but essentially you assign it, you create a temporary directory and you clean it up. And this is roughly what this would look like if you're running it. So you make your temp directory, you export it as a variable, you use it, so you write your content to that directory during the course of your script. Crucially, you make sure that you copy everything back off of it, and then at the end of your script, you check if that directory is still there and clean it up. Otherwise, you can kind of, you're essentially taking up space on the local storage. I mean, it will get cleaned up automatically after a time. So as soon as your job finishes on the node, we have various kind of workers that go around and check scratch storage to see if there's any storage that's owned by a particular user who's not currently got a job running, and it will be deleted to kind of keep things neat. But again, kind of that's an important reason to make sure that you copy everything back afterwards. But just as kind of good practice and kind of being a good HPC citizen, make sure that you kind of clean up your jobs after you finished using that space. So that's scratch storage. Interactive jobs. So this is a slightly different way of working. So this is for those who want to be able to work in a command line interface type scenario. So as we've got here, so I've got I'm currently on a logger node, but you want to be able to actually run stuff and test stuff on sort of via the command line interface, but not on a login node. So this is why we provide something called Slurm Interactive. So if I module purge, module load BlueBEAR. Let's just clean that out. Module load Slurm. So Slurm Interactive just provides a bunch of wrapper scripts essentially that allows me to, or allows the user to start a job and then actually drop you onto that running node. Now this practice has been potentially sort of slightly superseded by what I just showed you on BlueBEAR portal, where you can obviously start something running, so just a code editor, but then you can just jump onto that node and essentially do the same thing, effectively have an interactive job on that node. But you might not like the terminal that BlueBEAR portal provides. You may have sort of other preferences. So we like to cater for everyone's needs. So FizzBatch screen. So FizzBatch is I can't actually remember what it stands for. It's essentially an interactive SBatch. There are two different flavors. There's FizzBatch screen and FizzBatch TMUX. If you know your terminal multiplexers, then that may interest you. Otherwise, use FizzBatch screen. It's fine. So I'm going to ask for a little less resource because I want to get on this quickly. I'm going to put it on BB short, and I'm going to ask for just 10 minutes. And then I will let that sort of chunder away at some point. Hopefully that will come to life. Given that it was taking a while to get onto Nodes earlier, that may not happen instantly. But there is more information about kind of using FizzBatch and using interactive jobs on the BlueBEAR pages. I'll just leave that running away. I mentioned email notifications earlier. So you can specify what sort of detail you want, whether you just want it when your job fails or whether it finishes. There are occasions, I don't think they're very common nowadays, but where, because of the way that your university account was initially set up, it may be that you aren't receiving the emails. In that case, you can override the email address for the kind of the mail outs. Oh, that's about to start. So just jump back over here. So it tells me I'm connecting to it, etc., and I'm now on that node. So I can see what type of node it is. So I'm on a cascade node. So all of the login nodes are all Haswell nodes. So I'm on a different type of node architecture. But now I can carry on and start loading my MATLAB or my Python and working without fearing that you'll get an automated grumpy email from the BEAR team saying, please don't run jobs on the login node. So this allows you to essentially run jobs as if you were in a command line interface environment, but not on a login node. So you're actually on a compute node here with potentially more resource. In this example, I only requested one core because I didn't want lots and a short amount of time, but you could have more significant kind of core usage than that. And it could be a multi-node job as well. In the case of a multi-node job, you'll get connected to the head node, which is the kind of the orchestrator node of that job, but you'll be able to farm out commands across the entire kind of, across all of the nodes you have as part of that running job. I will exit that now because I don't need to use it. So that is interactive jobs. Jumping back over here. So you may find that you need to override the email. That's how you do it, but there's more information about all of the email notifications on the SBatch pages on the Slurm website. Oops. So Slurm arrays, I've mentioned this a few times before. So arrays are great, particularly if you have sort of certain types of operations or workflows where you need to crunch vast amounts of data, but in essentially the same way. So if you're pre-processing like a directory with 10,000 files in it and you're doing exactly the same thing to them all, you're chopping and changing them, or you're doing some kind of very sort of quick analysis, then this type of approach can work very well. So essentially you include this line, SBatch minus array, the size of your array job. So that's the index of the array job, and how many parts, how big the array is, and you include that in your SBatch headers. And then what will happen is your job will be kind of essentially multiplied across BlueBEAR, depending on how you've assigned that array. What happens when you run an array job is you get a few more environment variables. So as you can see at the bottom here, you've got your Slurm array task ID, and that's the thing that you can use to differentiate between jobs in an array. So in the case of processing a large kind of number of files in a certain directory, it could be that you have a text file that you use to alias file names to kind of task ID. So you can say, okay, if it's task ID 1, that's this file name, task ID 2, etc., etc. You could rename your input content so that it matches a task ID. There are various different approaches, sort of some more destructive than others, but essentially you'll have to wrap your script in such a way that it can cope with, that it can operate over kind of a large amount of content and kind of different input data. So it needs to kind of use variables in that way. But other than that, it can be very powerful, and you can, I think the maximum is 4,095 jobs that you can submit as part of an array. So if you need more than that, you'll then have to submit, say, two 2 array jobs, and you can get them to run in dependencies as well. So if I go on to the next page here, job dependencies can be very handy, again, actually coupled with array jobs. So say you need to pre-process a bunch of data which is better handled as an array, you could set that running, and then you could write another sort of SBatch job and pass in this argument, minus dependency equals, after OK, so that means that the previous job completed successfully, it didn't error out, and then provide a job index. So that means that as soon as that previous job finishes, then your next SBatch job will be submitted. So it allows you to kind of even sort of pass even more of it over to the scheduler, so you can schedule everything up, kind of rack it so that it's going to execute in order, and then sort of walk away and come back when it's all finished. So it'll do the pre-processing as an array job. It then may do a chunk of sort of further processing, not as an array job, depending on the type of data you're working with, and then potentially another array job at the end, which then sort of farms it back out again. However your workflow works, but it just gives you different sort of options. So that's job dependencies. Just sort of generally talking about resource, so aim to be as accurate as possible. So using your scontrol output and looking at the Slurm stats file to sort of determine how much resource you're actually using. So don't request 3 gigabytes of RAM or many gigabytes of RAM if your job actually doesn't require more than a few kilobytes. Likewise, kind of have an eye on your wall time, so run some smaller jobs first to kind of do tests. If possible, if you can break your work into smaller chunks, it means that if there is an error, or if there's a fail, or if something goes wrong in the system, it means you don't lose sort of 10 days worth of work. So if it is possible to make things kind of in smaller slices, then that's a good idea. Not always possible, I understand kind of the different workflows. Always ask for a little bit more on the wall time, because essentially as soon as that wall time is hit, your job will get killed. And Slurm isn't aware of, if your job's been running for 9 days and it was just about to finish in sort of 30 minutes, it has no understanding of where your job is. It just knows that it's past its wall time and it will kill it. So always make sure that you allow a bit of buffer there. If it, for example, it's a slow storage day. There is help available. I say that my mouse has just disappeared. This occasionally happens with Zoom, I find, on a Mac. So if I can't go any further on these slides, I do apologize. If you go to, I'd like to make that slightly bigger, but I can't. Oh, that's not what I wanted it to do at all. Okay. Where's that? I do apologize. I'm just going to have to kind of trundle on with it in this format. Oh, there we go. It's back. Apologies for that brief hiatus. Okay, help is available for me. So if you go to the service desk, you can submit various different requests. So this is where you can request software advice. You can ask for an application to be installed, general help with BEAR compute, another BEAR request, various different options. But if you essentially go via the research tab on the service desk, that is where you will find us. I've mentioned some of these other services before, but there's the Research Data Store, as you know, BEAR Data Share, which should be removed from this because it is going, but that was our sort of Dropbox style system. The Research Data Network, this is changing slightly at the moment, but essentially there are situations where we can provide sort of faster interconnect for certain types of sort of equipment on campus, but I think that the model for that is slightly changing across the university. They're going to a centralized model. BEAR Cloud, so BEAR can provide VMs. In the majority of cases, we prefer people to use a batch workflow or use BlueBEAR portal. So historically, BEAR Cloud was useful for kind of providing access to GUI applications, but those workflows have changed slightly. And actually, the problem with VMs is that they are resource limited. Whereas if you've got access to the whole of BlueBEAR, you can kind of batch compute across the entire cluster. We also provide sort of a BEAR software advice and kind of coding assistance. So we can help kind of advise RSEs sort of across the university and researchers on sort of good practices, on sort of helping with them develop their code. In certain situations, we can do some coding for you. So I think it's up to, I can never remember, it's either 10 or 20 hours of kind of coding that we can do for free as sort of part of that service. But there's more information if you have a look on the intranet. There are campus groups, so there's a Birmingham RSE Slack channel for basic kind of research information. And additionally, there are sort of special interest groups run outside of advanced research computing, so for bioinformatics, CFD, MATLAB, Stata, etc. So there will be other people who can potentially advise better than ourselves on certain kind of application approaches. And that, I believe, is everything. So thank you for your time. And if you have any questions, do give us a shout.